How many here are born after 1995? Okay, a couple of you, yeah. So you weren't born when Java was created. It's 30 years this year. That's pretty amazing, right? And one of the reasons it's so amazing is that we keep up with the new technologies. And a very fundamental reason to why Java is here today is J2EE. Anybody remember J2EE? Yeah, so back in 1999, J2EE came about. And that was because Java was originally created for set-top boxes for TVs. It wasn't created for servers. It was created for gadgets. But it soon turned out to be very good at server development. So backend took over, and J2EE was created and conquered the world. This is what pays your bills. This is why Java is around today. This is why this is not a .NET session or C session or something else. This is why Java is still here. That's the enterprise Java that came around there in 1999. But of course, it was very over-engineered and a little cumbersome and a little bit tricky to use. Those who remember, it was a lot of deployment descriptors and interfaces and stuff to implement that nobody had a clue what they were doing. So Spring came around to try and simplify this. And so we went from one sort of XML deployment descriptors to another XML file. Like you remember the, what was it called? The application XML or whatever, in framework XML in Spring. Remember that file? It was like 3,000 lines long and had references to other files. So if you wanted to figure out where a bean was created, you had to search through all these XML files and try. So we went from one kind of hell to another. It was a little bit better, but still. And then luckily, Java EE, or that's when J2EE changed name to Java EE, and we started using annotations for some of the configuration. So we went away from XML gradually over to a annotation-based configuration model, and that's when the Spring guys developed JSR 330. So you can use add inject and add autowired in Spring interchangeably. So it kind of hooks into the Java injection mechanisms. And then at that time, when Java EE was around Java EE 7 and Spring was Spring Framework 4, they were very comparable. Maybe Java EE was a little bit better at some points and less verbose. And then Spring Boot came around in 2014 and everything changed again. The Spring Boot has sort of conquered the world again. So anybody using Spring Boot? Yeah, okay, most of you, good. So Spring Boot is kind of the de facto thing you would use today. And some of this talk is about why Jakarta EE is a very good alternative to that. And Jakarta EE came around in 2017, and that was Java EE that was moved from Oracle over to the Eclipse Foundation and developed truly in open source fashion. So everything is open source. And that started in 2017, we did that transformation. And of course, you probably noticed in 2020, when we released Jakarta EE 9, we changed the namespace. And that hit the Spring community like 2 years ago or so, until last year. I guess all of you has done this transformation. And you can see how much impact Jakarta EE has on Spring. So everything you do in Spring is actually based on to some degree on Jakarta EE. And then now we're talking 2024, 25, we're releasing Jakarta EE 11. So I'll talk a little bit about Jakarta EE 11 and where we're at now, and then I'll get into the AI part. So Jakarta EE is all about specifications, not a Spring, which is a framework. Jakarta EE is about specifications. So we specify things in a specification, a human-readable document, so you can read about the technology. It describes the technologies. We have an API artifact in Maven Central that we as developers, that's what you see in your POM files. And we have a TCK or test compatibility kit that we use to test and verify that an implementation of these APIs and specifications fulfill all the requirements. And when they do that, they are a compatible implementation. And a specification needs at least one open source compatible implementation to be ratified as a final spec. So we prove that it's implementable. And these implementations, that's what you see in Spring. So when you're using Hibernate, you're actually using Jakarta persistence and implementation of Jakarta persistence, and so on. So currently, Jakarta EE is sort of the latest full release, but Jakarta 11 is halfway out there, or 2/3 out. So Jakarta 10, after the namespace thing in 9, we only changed the namespace in Jakarta 9, and that was because we wanted that migration to be easier. Because if we had changed the APIs as well, you can imagine how that job would have been. So we kept it to a minimum. So we had a lot of specifications that needed updates in 10, and all the blue ones there were updated in Jakarta 10. And this kind of continues. If we compare this to 11, we can see that there are still a lot of specifications updated in 11. So this is evolving technologies, and all of these things, or most of them, are in some way or the other picked up by Spring. Because at Spring O last year, they announced that Spring Framework 7, which is in some version of milestone or release candidate now, that picks up the Jakarta EE 11 implementations of these APIs. So even before Jakarta 11 is fully released, Spring is using it. So you're using the latest version of Hibernate, you get the latest version there. You're using the latest version of Tomcat in a Spring Boot application, you're using the latest servlet API. So you're already on Jakarta 11, whether you like it or not. And if we look at 11, we have the Jakarta EE platform. And that is a specification on its own with compatible implementations, and has all of the specifications included. That is in the Jakarta 11 umbrella. A subset of this is a Jakarta 11 web profile. And the web profile is kind of more targeting web applications or traditional web applications. But you have everything you need from persistence to security and UI and whatnot. And then in 10, we introduced the Jakarta EE core profile. So the Jakarta 11 core profile also received some updates. And this is a profile targeting smaller runtimes, those you use for microservices. So it's about the RESTful endpoints and the JSON back and forth. And it also has a light version of CDI that can resolve all the dynamic properties that CDI usually does at runtime or deployment time at compile time. So you can use GraalVM and compile native images if you want to. So we kind of address these kind of newer trends in some ways or the other. Jakarta 11 is based on Java SE 17, which may sound old. How many are on 17 or newer? Most of it. Any on 8 still? Oh, good. So we're at least on 11 then. Yeah. So we're basing the APIs on 17, but that doesn't mean that we don't support newer versions. We make sure that the TCK runs on 17 and 21. And that's because we see 21 being the next release after 17. Everybody is kind of following these LTS kind of train. So you can use Java 21 with Jakarta 11. All the demos I'm going to show on today is on Java 24. So we also support the newer versions. With this, we establish a release cadence of Jakarta EE that is sort of a 6 to 9 months after the latest version, LTS version of Java, which is perceived as LTS in the community. And so after 21, about 6 to 9 months after, that should have been last summer, Jakarta 11. We were done in May, but we still needed to do, with all the implementations, so Hibernate and Tomcat and everything, implemented Jakarta EE 11 APIs in May last year. The reason why we aren't fully released yet, we're still at the milestone, is that we're refactoring the TCK, because it is written with a test framework that was developed back in 99. It's older than some of you. A 30-year-old test framework that we cannot get any new developers to use this. So we're changing it to use at least JUnit and Archillion and Maven and some newer kind of things that everybody is familiar with, so we can get more people to contribute to the TCK, because it's open source and it's community that creates it. And if we have some old crappy technology that nobody knows, we won't get people to help us. So that's why we're putting a lot of efforts into doing this refactoring And it may take a little longer, but we will get there. And the status today is that in Q4 last year, in December, we released the core profile. In April this year, we released the web profile. And in beginning of June, we will release the platform. So we will be 1 late with this release. And that is because we're refactoring the TCK and doing this investment now. So the AI part, what you're here for? Yeah. Not yet. I said you were screwed coming in there, but yeah, no, don't worry. This is fast. I'm going to show a couple of the technologies of Jakarta EE that I'm going to use in the demos, just to make sure we're on the same page. So I'm going to create RESTful endpoints. We'll be using Jakarta RESTful Web Services, or maybe some of you knows it as Jakarta REST. Some of you may even if you're a Spring developer, use Jersey with Spring, and Jersey is implementation of Jakarta RESTful Web Services. So is it similar to the REST controller in Spring? And I'll show you the differences, but you will get it. It's very similar. What they're doing in the 11 release of Jakarta RESTful Web Services is sort of maintaining a little bit of legacy things they have had around. Specifically, the last step, they're mentally preparing themselves to get rid of their native component model, because they have their own resources and context and injection stuff that you don't really need if you're part of the Jakarta EE platform, because you have CDI and dependency injection there. So we're kind of trying to move them over to a standard technology and not use it, something they've created themselves. And it's also, they're doing some minor updates here and there. And if you want to learn about Jakarta RESTful Web Services, the best place to start is at the specifications folder on the Jakarta websites. There you'll list all the specifications. You can just find whatever you're looking for, and usually the latest version is the most interesting. And the latest version of Jakarta RESTful Web Services is 4.0. Then I'm going to use CDI, but that is mostly because that is the component model we're using in Jakarta EE. So if you're a Spring developer, you used to just use the Spring mechanisms and auto-wired or dependency injections that you get in Spring and the Spring bean managers and stuff. Well, this is the same thing, just in Jakarta EE. What they did in the latest version is to support records and seal types, so you can inject these as well. And priority and producers, which I could have demoed in this, but it's kind of not really what we're going to show here today. And also, we're moving the integration requirements of CDI over to the platform specification. And these integration requirements are mostly about how CDI integrates with EJBs. Remember EJBs, that was kind of developed in J2EE back in 1999. It has been modernized. So modern EJBs are way different from what was initially gave J2EE a bad reputation. But still, EJB, when I mention it, people were, oh no, you know. And so while it's a good technology, we see that people have this kind of bad memories about it. So let's just use CDI instead. So we're preparing ourselves to kind of phase out EJBs, so we can use the alternatives in CDI rather. And one of those steps is to move those integration things over in the platform, so CDI is kind of free of it. All right, this is the last one I'm going to talk about before we go to the code. So JSON binding. JSON binding helps us take JSON and create Java objects or fill out of it. So and it can also create records. So if you have a JSON string like this, you can automatically bind it to a Java object like this using JSON binding without writing any code or any configuration or anything. It will just happen by automatically, and that is because in this case the name has the same name as the parameter, and the same with the greeting. So if I had different names of my parameters or members in my class, I would use some annotation to map it. But if it has the same name, you can just use a regular POJO. So JSON binding is in version 3.0, also under the specifications directory. So I'm going to talk about data as well. I'm not going to demo it here, but if you want to see a demo of data, you should come to my session tomorrow afternoon. Then I'll do a demo of everything that is in Jakarta data. But it sort of looks like this. And you would say, well, I know this because this is Spring Data. Spring Data JPA, right? Yeah, so this isn't Spring Data JPA. This is Jakarta data. So we're not stealing it. But we're standardizing it. We see this is a good thing. This should be a standard. So we're creating a standard out of it. And maybe it will be picked up by Spring in the future because JPA, that's Jakarta persistence. Spring is already using that directly through Hibernate. Hibernate implements Jakarta data. So there is maybe not a reason for Spring data when you're using JPA anymore, when this is kind of getting picked up. You can convert the code by just switching the imports. For the simple case. We also add some things. So it's a little bit more powerful than Spring Data. We add Jakarta Data Query Language, which is a subset of the Jakarta Persistence Query Language. And the way you can use this is you can write your queries in an annotation like this. And this is a little bit more robust than relying on the method name. Because if you have some new developer coming in, hey, I'd like to rename a method, and renames it, then it will do something else. Right? So this is a little bit more robust way of writing that kind of code. And there is an opportunity if you want to make a name of yourself, get a Wikipedia page, and be a hero in open source. You can create an implementation of Jakarta data either at Apache using the OpenJPA or at Eclipse Foundation using the Eclipse link. So having an implementation right there. There are some initiatives in Eclipse link at least, but over at Apache, I don't think OpenJPA has done anything yet. So that's if you want to really dig into some code, and then you have a talk at conferences for years going forward, if you want to be a speaker. All right, AI. So I'm going to jump right into a demo here, and this demo is to show that you don't need to learn Python to use Jakarta, to use AI. And because in early days of AI, everybody, the model is written using Python. We have to learn Python to use it as well. So I'm not going to talk about how you create the models. I'm not going to create how you configure the stuff. I'm just going to talk about how you use them, how you integrate some AI stuff in your enterprise application. And anybody using AI in your work today? Some of you. So this won't be new for you, probably. But there are some new things. But usually, I think you can agree with me that you have an application out there, and you have an AI model somewhere, and you call it. It could be an AI model you have in your company, using your company's data, that you've trained and built yourself, or it can be using ChatGPT. But it's the same thing. You're just calling another system. And calling another system, that's what we have been doing for 30 years and longer before Java. Calling another system isn't that hard. There are so many ways of doing a call to another system. And that is how I'm going to show that Java is the best platform to use if you're integrating AI into your system. And if you already have a Jakarta EE application or Java EE even, this is a very easy way of getting AI in. You don't need to go to Spring to use Spring AI. You can use the technologies with Jakarta EE. So this is the application I'm going to use. And in the demos I'm going to use, my AI is going to be OpenAI. And that is because I'm a little bit lazy and a little bit cheap. So I paid $5 to OpenAI to get an account, and I'm using those $5. And I don't want to pay anybody else. So that's why I'm using OpenAI. If you're using something else, whatever AI, just replace whenever I say OpenAI, replace it with your AI, because it's the same thing. And of course, Spring is very good at AI. Anybody using Spring? yeah, I don't know, but Spring AI. So you haven't tried Spring AI, okay? So that's good because I have a demo on Spring AI. Imagine that. A Jakarta EE developer advocate comes here and show you Spring AI. Huh? That's cool. So, and this is Spring application calling OpenAI. So let's have a look. So I'll open this one. And we'll go to the Spring AI demo. And we'll look at the POM file first. So I'm using 3.3.9 of Spring. I know it's not the latest, but it's fairly new there. And anybody using older than 3? You have Spring with 3 at least. So yeah, so I'm there with you, sort of. And I'm on. We can use Chun 4. I've used Spring AI milestone 6. I think there is a milestone 7 out there, but milestone 6 is good enough. All right, okay. So it's fairly new, and what I have there is I've created this on the Spring initializer. So I chose the Spring Startup Web because I want to create a RESTful web endpoint, and I created with the Spring AI, I added the AI. So I got this thing. Everything else is just the regular Spring stuff they generate for you. The application is, I have this Spring Boot application. Nothing weird. I have a Spring AI resource where I have the REST controller, right? I'm ordering in a Spring AI service. I'll explain later why I do this, because I could have done everything here in this classroom, but I'll explain why it's a good idea to put this out. It's a get on /AI that takes in a message and calls this AI with that message. So it's not that fancy. It just gets something from the internet and throws it on AI. And then the component, the Spring AI service, that's where I'm going to implement now. So this one is going to call the AI system. There's one little configuration I have, and that is the context root, and also my OpenAI API key. Of course, I don't show it here to you, right? Because I have $5 there. I don't want to use the. So yeah, and this is also a good idea for you. You shouldn't put it in your code. Put it somewhere else. I put it in my system properties. But if you're Kubernetes, Docker, whatever, put it in a secure place. So what I'm going to do here, I'll use AutoWide because I use field injections. I like them. I don't know what your flavor is, but I'm integrating here the chat client builder from the Spring AI, like the Spring AI chat client builder, and then I'm going to use this builder. And what do you use builders for? You build something, right? And then I'm going to prompt this AI system with the message, and then I'm going to call it, and then I'm going to get the content from it. And as you see, these AI things kind of keep generating things that I don't like. So don't use AI. Be wise. I'll just see if I can get rid of this AI assistant. Disable for this project. Yeah, screw AI. We don't need it. So here I'm building it with a builder. I'm prompting with a message, and I'm calling it, and I'm getting the content out of it. So that's very fluent, easy, isn't it? So I'm going to do Dix Spring AI, Maven clean package, and oh wait, wouldn't build. What does it say? Crap! Did I do something wrong here? Dix, what does it say? Look at this, different. One failure. It's some test case failing, isn't it? Yeah, so let's take the tests. This is actually for my later demo, but let's delete the test. We don't need tests. Who does tests? Nah. So it still doesn't work. Okay, so SDK is Java 24. So I was on 23. So that explains it. So I didn't have to delete the test. Or why? 24. Maybe it doesn't support Java 24 yet. So let's go with 23 on this one. There you go. So Spring 339 doesn't compile with Java 24. Good to know. And now I can start it Java jar and Spring jar, and then I'm gonna tell me a Java joke. So now it does can we read it down there? So it gives you a bad joke. So let's do it in Hindi. So you can see it does call out. I don't know if this is better. Yeah. So you see it works, and how simple it was to integrate that AI into that system. It's just call another thing, and Spring AI is pretty awesome in that regard. It's very easy to use. So that's Spring AI. But we have other things as well. Anybody using Quarkus? Heard of Quarkus? Okay, yes. So Quarkus is Red Hat's kind of answer to Spring Boot. And it is more closer to Jakarta EE. It's more the programming model we are used to than Spring is. So I'll show how Quarkus does it. And the application here looks like this, exactly the same. It's a Quarkus application calling OpenAI. And as with the use case is going to be exactly the same. So you'll get familiar with the structure as we go. So the Quarkus application, this one actually I've verified runs on 24. And it's the same kind of way of configuring as Spring. So I just add the dependency, the Quarkus REST for REST endpoints, then the JSON-B for binding JSON. And then I add a Quarkus LangChain4j OpenAI thing. That is their AI library. The application here, not the Spring application, the application here is looking very much similar. I don't need any configuration other than the same API key that I have with Spring. Then I can just create the resource directly. So this is kind of the REST controller in Spring. It has the at path annotation. That's going to be at REST controller annotated. And then on class level, then I inject the AI service the same way as I did with Spring, a different component. And then I have a at get. This is the at get mapping for Spring. Get, and it produces text plain. It takes in a message from the query, from the input, and calls this AI service. And this AI service in Quarkus is just an interface. And the way I make this a AI thing is that I call the register AI service annotation on it. And then on the call method, I give it a user message. So it's a message from the user, the message, right? So this is all I need to do. I could have done a lot of system message and a lot of other configuration to kind of configure the model in a way like do this in that way and set the language, for example, and all these kind of things. You can do with the messages, but this is the bare minimum. I just need the user message. So if I'm going to call this one Quarkus clean package Quarkus run, we'll start it up and I'll do the same call. We'll give it in there, so it will call the AI and come up with a joke. So this is how easy it is to use Quarkus. And you see, it's, even though Spring AI was very simple to use, this is even simpler. And this is more a Jakarta EE programming model. So Quarkus is a good alternative if you want to just try it out. Then, how about Jakarta EE then? Do we have anything to support the AI thingy? Well, actually we do. So I'm going to show an application which is a pure Jakarta EE application, no dependencies, nothing else. It's just Jakarta EE. And I'm going to call OpenAI and do the same thing. And then I'm going to take that demo and I'm going to make it better and better and better as we go. So the first one will be a little cumbersome, but we will get there. I'm just going to walk you through how it's configured. I'm on 24. I'm using the latest version of the Web API, which is 11. It's a provided dependency, and this is one of the advantages of Jakarta EE. You don't mix your APIs into your application code. Everything is provided to you by the runtime you're running on. So your code itself, it's just a couple of Ks. It's a small file, no dependencies needed, unless you drag in some libraries, of course. And that means you will have less vulnerabilities. If there comes a log4j or something else in some dependency out there, in Spring, you have to wait for the next Spring version, or you have to go in and configure all your POM files. In Jakarta EE, it's just let the vendors handle it. So I have configured a couple of plugins to run it. So I'm running it in OpenLiberty from IBM, or I can run it in Whitefly from Red Hat, or in Payara server from Payara. So it's not dependent on a specific implementation of vendor. So we can move it between vendors if you like to. I'm going to run this one on OpenLiberty because that's has a nice fast feedback loop. Here as well, I have to have the application sort of like the Spring Boot application. It's the application path annotation, which is from Jakarta REST. So this is a Jakarta REST application. And here I can put some configuration if I have any. Then I have the resource, which is exactly the same as I had in Quarkus example. It's the @path annotation. It has the @inject the client or the component outside. And I have get a query param message and call AI, which I'm going to implement. And since you see, I don't use any dependencies, and we don't really have any specification for AI yet. So I don't really have anything directly supporting any AI model in Jakarta EE, but luckily all these AI providers, all these models have a REST API. So I can just call a REST API, and REST API is something we know. We've done that forever. So here is and AI is moving a little bit fast, and this is kind of a learning point for you. It's that when I created this demo, this wasn't legacy, but it is now. So they say you should use something else, but then I have to change the demo. So I'm just using this legacy, but if you repeat it, do it at home, just read the documentation and call the other service, because it does the same. It's just they've changed the APIs, and they do it all the time between milestone releases and everything. So, but the concepts are the same. So what you do here is you call a completion with a small object like a prompt, which model to use, and some stuff. And then you get a completion response back. And you remember the JSON binding, that takes a JSON string and creates a Java object. So I want to create this JSON, send it over the REST API, and I get some JSON back, and I want to have it as a Java object. So I'll have to create those Java objects, unless I'm using some kind of client that also already has it for me. But here I'm using the bare vanilla thing. So what I have to do is to create a completion object and a completion response object that maps to those JSON strings that you see here. So I'll do that. I'll create a new Java class, completion, and I'm use the completion template, so I don't have to write it. And what it does there, it maps to this JSON that you just saw. And the other thing is I have to create the completion response, and also cheat a little bit here and create the response. And it kind of creates the bare minimum, so I can kind of nest myself down to the content that has the message. So that's kind of the minimum structure I need to create that. I don't have to specify all fields, because the JSON binding will just map those that are existent. And as long as they have the same name, I don't have to do an annotation. If I had another name for choices in the JSON, I would have to use some kind of binding annotation for that. But this is kind of the easier way. So now that I have this, I can create this request object by instantiating this completion. Say I want the GPT-4o model. I want the role as a user. Set the content as a message I'm getting in. Tell me a joke, kind of thing. Then I'm going to instantiate a client. And this client, that's a Jakarta REST client. So we already have these clients we're calling RESTful APIs. And then I'm going to do the response. So to take this client and call this endpoint, the one I have here, and set the header, the authorization header, to be the API key. And then the entity I'm sending over is the completion object I've created here. And then at the end here, I'm going to do I get the content from this request. So I'm going to take this response that I'm getting from this client call, read the entity into the completion response object. So this is where the JSON binding happens. And then navigate down, get choices, get first, get message, get content, which I'm interested in. Of course, there can be null pointers and stuff if the JSON isn't there. So in production, you would do something better than this, but this is good enough for now. So this is the thing I have to do. Just set up the request, call the stuff, and get the response back. So it's kind of the same thing. It's a little bit more verbose than Spring AI and Quarkus, but it does the job. So let's try it out. Jakarta, now Dix, Jakarta AI, and I'm going to main clean package, Liberty, dev. So this one will run it in oh, yeah. Thank you. That's why you do this on stage and not at home, because at home nobody will help me. So there you go. So this one will start up the Open Liberty I've configured in my POM file, and it will start it in a dev mode, so I don't have to restart it when I do changes, which is convenient when we're here. In production, you will obviously run it in production mode. So now if I do the same call, it will do it for me. What's the local language in here in Bangalore? Karela, like this. So, once more. Okay. Canada with dominant. Okay. This. Yeah. So maybe it will work. I don't know if it's worth it. It's good. Is it correct? Yeah. Well, there you go. So, but this is a little bit too verbose and a little bit, it's low level. And when they change it, they did with call this legacy and move to another one. You have to change those completion objects. You have to change how you do the endpoint, and so it's kind of, you have to have a fairly stable API before you want to do this kind of thing. But you have total control over it. There are no dependencies, no vulnerabilities that will ever come in unless you introduce them yourself. So it's a very safe way of doing it, but it can get a little cumbersome if you're doing a lot of calls over this. But it is a way of doing it if you don't want to have any libraries in your application. But of course, there are some libraries that are fairly good out there. And anybody using LangChain4j? Heard of it? Yeah. So LangChain4j is sort of becoming the de facto standard for calling AI systems with Java. It is a source thing, kind of lots of Reddit developers contributing to it, but it is on an open source project, which is a good thing, right? So if I wanted to use LangChain4j in Jakarta EE, that's also very simple. So let's just go out here. If I wanted to use LangChain4j, I can just add those dependencies. So I'm kind of yeah, you have to add some dependencies from to your pump files, but if you limit it to those you want to have in, and you kind of hope that they don't drag in too much transitivity, and well, sometimes you need some libraries. You don't want to code everything yourself. So you'll see this is much simpler. So if I go back to the application and use LangChain for J directly, I'm going to do it in here. So I don't really need this OpenAI client anymore, because since this one is the manual thing. So here I'm just have to reload the POM file, because I'm realizing I'm using IntelliJ here. If I was using NetBeans, you wouldn't have to reload a POM; it will do it for you. So if I want to use LangChain for J here, I can go in to this one. Let me see if I remember this correctly. I can just do the OpenAI language model, the builder again, like the Spring example. Give it the API key, build it. Then I can use this model to generate the message that I'm getting in and get the content. So it's a very fluent, easy to use API to do this stuff. And if I want to call this one, I can do it. And now it will use LangChain for J to do this call. So let's go back to Hindi, so we can understand it, right? So it writes something. I'm not sure if it's funny or not, but it's you can see it does the work for you, but it's not really the programming model we like in Jakarta EE, because we like dependency injection. And LangChain for J, using this as a direct library, it's kind of it's there, it works. But let's see if we can use CDI to do this, to make it injectable. So I'll go back to the demo here, and to use CDI for this, I'll create a producer. So I'm calling this OpenAI producer. I'm going to give this one a CDI scope. Let's use application scope. Application scopes. And I'm going to produce. And here is where you have to be a little bit careful, because there are two producers in Jakarta EE. One is, like for a RESTful endpoint, you produce it JSON through the API. The other one is to produce CDI beans or objects in your CDI producer. So I'm going to have this this one. I'm not sure if this is actually correct, so I'm just going to write it myself. Open AI language model, get model, like this, and then I'm going to just take from this one. No, the one I'm using here. So I'm just going to create this model here. Take this. Didn't I turn off this AI shit? Return AI model build, like this. So now I'm creating the model in a CDI producer. So in this one, I can now use add inject, open AI language model, and I can use this model directly to call. So now I'm having CDI produce this model for me. And this is a model we generally like more as a Jakarta EE developer. So I'm injecting the stuff and using it. And to prove that it works, I'll do the call again, and we'll see. Maybe in English. So it calls out and does the work. But what if I really like Spring? And Spring AI is awesome. And this is what I want to have. Well, the good thing is you can use that in Jakarta EE as well. So remember my Spring AI application here. So if I want to use this in my Jakarta EE application, I could just add this dependency in my POM. But in order to do that, I have to fix it a little bit, because a jar file that is produced by the Spring Boot plugins isn't a regular jar file. It's not useful for us. They do some magic tricks in there. So what I have to do is to get rid of the Spring Boot Maven plugin, because I'm not interested in running it as a Spring Boot application anymore. So I'll just comment out the Spring Boot plugin, and this is where you usually don't want to take a application to do this. You just create a library using the Spring Boot APIs to do this. So what I'm interested in is this Spring AI service, and I just need something that gives me the Spring context, and that would be the Spring AI application. This one I'm not interested in at all, because I'm not going to use that one. So if I created a Spring component, I would only have the kind of what creates the Spring, probably not a Spring Boot application. It would be a Spring Boot something, and then the service I want to call. And this is why I put it outside the REST controller, so I can call it from other places. I have an example of it here, where I don't have the application, but for this demo, I'm going to use the one I used in the demo. So when I've done that, another thing you have to do is, since I already deleted the test, I don't have to think about it. But since I'm not using the Spring Boot Maven plugin, it will actually fail, since I have a test there and then there is no Spring context created, and so the tests will fail. So you have to get rid of those tests and rewrite them as well. So to use a Spring Boot application, you delete the test. But I already did that, so we're good. So what I can do now is go to the Spring AI, and now rather than just packaging it to run it from my target folder, I have to get it into the Maven repository so I can consume it. So what I'm going to do is Maven clean install. This is when you use install, isn't it? To get it into my empty folder, so I can consume it from the Dux AI. And then I have to go to my Jakarta EE application here, and I could get rid of the LangChain4j stuff. I don't need that anymore, but I'll just keep it there so we can see the different alternatives. So I want to add a dependency. Crap! I tried this. No, I didn't turn it off for this project. Disable layouts. It generates so much stuff for me, but this is JetBrains, I think. So let me add a dependency here, and I don't want this thing. I'll just manually type it there. / dependency, and I want to add the artifact ID. What did I call it? Was it Dux? Let's see. AI Dux Quarkus, no, Dux Spring AI. So we're here, we have Dux Spring AI. So I'll add this one, AI Duke, and version 001. So now I've added my Spring Boot application into the dependencies of my Jakarta EE application. And now I can do the same trick as I did with the LangChain4j, is to create a producer for this. So I'll call it Spring AI producer. I'm going to give this one application scope. And here as well, I'm going to have an @produces. Or actually, I think I don't have to write this because I think I have some shortcuts for this. So I need to do three things. First is I need to kind of have the Spring context available for me. So I'll just have the Spring context given this. Then what I need to do is to register the Spring Beans with this Spring context. So what I'm doing is I'm creating an annotation config application context, and I'm registering the Spring Boot application to my context. And the third thing I'm going to do is to get the bean from that context. So what I'm doing here is to call getBean with that Spring AI client from the Spring context. And now I can go to this resource, and rather than injecting the OpenAI thing, I can add inject the Spring AI service model. And now I can do the return model. Was it generate? I call this one, and with the message like this. Or did I call it something else? Let me just check this one. Spring AI service. Yeah, I have to get the content like this. So now I'm doing the same thing as I did with the Spring thing, but I'm injecting a Spring application into my Jakarta EE application. So this is kind of scary. Sorry. Yeah, let's get rid of this one like that. So, call. That was what I was after. So I called the wrong one. So this one returns a string. There we go. And the message as well. So, let's see if OpenLiberty was able to do that. So what did I do now? I didn't install again. Like, let's see. I don't need that. Let's do tell me a joke. And I think OpenLiberty got too much of stuff going on. So let's restart it again. If you do too much compilation errors, it will get a little tricky on you. There. Okay, it's getting up. There we go. So now it calls with the Spring AI. So that's pretty cool. Doing a Jakarta EE application, but I'm using Spring AI. Are we on time? 9 minutes, good. There is also a project called Helidon. And anyone heard of Helidon? Yes, so Helidon is Oracle's answer to Spring Boot and Quarkus. And Helidon is actually pretty cool. And Helidon is more in kind of the heart of Jakarta EE than any of the others, because Helidon implements Jakarta EE core profile as a compatible implementation. That's pure Jakarta EE. They also have some other stuff, but it is pretty cool. And I'm not going to do any long demos here other than running it, but I'll just show the code. So the Helidon, it's kind of the same way as you would do with the Quarkus and Spring Boot. You just add the dependencies you need, like OpenAI. And here, if you use anything else in OpenAI, you just add whatever model you're using. The LangChain4j dependencies. I can use the Spring things here as well. So the Spring, inject the Spring component works with Helidon as well. If I look at the code, you will see that it is exactly the same code as I had in the Jakarta example. It has an application path, the configuration, and here I have all the three ways of doing this. The one it is using is the LangChain4j, but I can change it to use another one if we want to use that. So use the Spring model here as well. It has a producer for the LangChain, and it has a producer for the Spring context. And I could have done the simple REST case as well. And Helidon is clean. Oh, I'll have to go to scene and take Helidon, maybe clean package. Sorry, did not change. Rather, so Helidon, maybe clean package. There we go. This one produces a jar, so it's not like all the Java EE application or Jakarta EE application that usually creates a WAR file. You can create a jar as well and bundle the runtime, but Helidon does that by default. So I'll just run it with Java jar, Doug's Helidon jar, and you can see it's fairly quick up and running. It's built from bottom up on virtual threads, so it's only on Java 21 and higher. And you see it works as a charm there as well. All right, let's wrap it up. So Jakarta EE 10, soon I'll change this slide to 11. It's the latest version out there. A lot of updates since the namespace change. Jakarta 11 is coming. It is out there in core profile and by profile, and the platform is coming in a month or so. So in 9 we did a namespace change. We're not doing that again, I can promise you that. We introduced the core profile in 10, and in 11 we're embracing records, supporting 21, making it more CDI centric, and adding the Jakarta data specification. And as you saw, 11 enhances the developer productivity and performance, and that's the title of my talk for tomorrow. So if you're interested in Jakarta 11, I will go through this in more detail then. It builds on 17, but runs on 21 and higher. All the demos ever are on 24, except Spring. That version didn't support 24 yet. So Jakarta EE works very well with AI. There are several ways of doing it. There is no reason to go to something else. If you're using Jakarta EE today and you want to use some AI system, even if you want to use Spring AI to do these things, you can still have your enterprise applications written in Jakarta EE. If you want to learn about Jakarta EE and do a LinkedIn course and get a certification on your profile, you can do this Jakarta EE overview course. It's on Jakarta EE 10, so it's soon going to be obsolete and probably updated to 11. But if you ping me on LinkedIn and say you saw my talk here, you can get the link for free. If you do this with your personal profile, it will cost you a couple of dollars or something. But ping me and I'll give it for free. So if you want to learn about Jakarta EE, you go to jakarta.ee. You get started. We have a starter on start.jakarta.ee, similar to the Spring initializer, so you can generate the project for you. The demo code is on my GitHub repository called Duke AI. And if you want to learn more about me, just Google.